Hello, everyone. I'm Randy Trong and my partner Andrew Yin, and our project is on human emotions during the pandemic. So, in general, we can all agree that the past many months have been straining and overwhelming. However, the COVID-19 pandemic is a great case study on human behavior. We want to explore how our current pandemic affects people's emotional capacities from social isolation or drastic changes, so we can then bring attention to those who may need support. More and more people are staying socially engaged and connected through online platforms like Twitter. And Twitter is a great hub for data about what people are openly feeling and thinking during these events, and also for mitigating the lack of physical human presence. Given technology's ubiquitous nature, we wanted to create a machine learning model that analyzes text-based emotions as a gateway for building future emotionally aware machines that can help recognize, treat, and understand health issues like depression and anxiety. So our goal is to predict emotion labels based on a data set produced from a NLP text processing model.
Okay, so I'm going to give you guys just a brief rundown of the kind of data that we're working with. So as Randy mentioned, these tweets were pulled from the Twitter API and then run through a natural language processing algorithm that processed for this idea of subtopics. And these subtopics, as you can see here, have a variety of keywords that are linked to it. And these tweets will be tagged to relevant topic clusters as shown in this following slide right here. That first tweet had the most relevance to topic 1 and therefore was tagged as such. Another 5 features that were also pulled is this idea of intensity, and this kind of measures the presence and degree of each of these emotions within a tweet. And these kind of properties were decomposed using another collection of machine learning algorithms. And I just want to reiterate that this is how the data set was put together. We did not do any of this language processing.
So given the large data set of roughly 75.6 million tweets, we decided to take a random sample of 1 million tweets to make our processing more feasible. In the next slide, I'll show the label distribution to see if there are any underlying skews in the label representation. And so then we used a Pearson correlation matrix to remove features that were highly correlated with each other to minimize noise. And our threshold for determining this was a coefficient greater than 0.8. And after this drop, our feature set reduced from 15 features to 10 features. Interestingly, this ended up dropping the sadness and joy intensities. We inferred that if the negative intensities are very low, then it is likely that the neutral and positive intensities would be high. So then we standardized the features using standard scalar and pipelining that data into our models. And since our labels were strings, we used label encoder to encode them into respective integer values, similar to our homework's binary labels. And currently we are still deciding whether we should clean the data from duplicate users, because one user could spam the data set with a bunch of tweets, thus fitting our model to their style of text and emotion. And then later we want to tune our hyperparameters for our models to increase our accuracy, because we haven't done that yet. And so here's the label distribution. We see that the 1 million sample follows a similar distribution as the original data set, and so we are good to train our model on our sample.
All right, so here are the models and results that we have obtained thus far. 3 models we have implemented are decision tree, random forest, and linear regression with HGD. Our goal for the final result, obviously, is to implement additional models, and the first one on our list is support vector machines. We feel that including this model would add a lot to kind of diversify the models that we would be comparing. Finally, our goal for this data and these models is to hopefully use this information to help individuals as well as help inform policy. So on the basis of individuals, perhaps if this model can detect if a human being is kind of like tweeting and it's able to detect that there's a gradual decline in their mental health, it could advise them to seek mental health services and or connect them to the appropriate resources. And on the basis of policy, we're hoping like maybe from a community standpoint, if a certain community is disproportionately affected by the pandemic, again, that policy could be used to inform perhaps support in whichever way they see fit. All right, thank you guys and take care.